Hello everybody, this is Michael. In this video, we will talk about the Synchronous FIFO 02. We will actually coding the Synchronous FIFO here. Okay, so first, from previous video, we know the Synchronous FIFO signal interface like this. Okay, so let's open our Visual Studio Code and the new file. Okay, and we save it first, and we save it in this folder, Synchronous FIFO version A. We will use another way to coding the Synchronous FIFO. We will have version B. For this is version A. So we save it into this folder. Okay, save it as Synchronous FIFO. Sync FIFO. And this is Verilog. So .v. Okay. So the first things we will create the module. Okay, module. So it is sync FIFO. Okay. So here we will input the signal interface. The first two is clock and reset, because the clock and reset for the most module is always input, so we can write it like this: input clock and input reset. Okay. Okay. The next thing is write input data. So it's here. Write input data. So input write enable in. So is this one. Write put enable in and input this data. We setting this data is 8 bit, so it will be 7 to 0 is 8 bit data input. Okay, and the next things will be the output full for the write data. So output, and it is a full signal. So this is for the write side, write data side. Okay, it's here. And for the read data side, okay. So this is the read data side. So the first thing is input read enable. Okay. The next thing is here is date out. Read from the FIFO. So it's output. And the date out, we make it as register, and also from 7 to 0 bit data output. Okay, and here is empty. Okay, so it's output empty, output signal. Okay, save it. So this is for the interface, signal interface for the Synchronous FIFO module. Okay, So we needed to edit the end module. Okay, so this is the module body. Okay, so next things we needed to define something. The first thing is define the pyramid length. Okay, from here to here. So we need to define the pyramid the depths for the FIFO. Here for our FIFO is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements. We can save 8 data into the FIFO. Okay, we can save 8 data into the FIFO. So next things we need to divide the FIFO. We have the depths. Okay, we need to divide the FIFO. Here we use array register. The data is also saved from 7 to 0 bit. It's 8 bit. It's memory, and the depth is from 0. The depth is from 0 to depth -1. Okay. So this we define the FIFO here. We define the FIFO here. Okay. So the next things we needed to define the write point. Okay. So we define write point. We define it as a register. It from 2 to 0. Write point. Okay. So you will wonder why is from 2 to 0 for the write point. Okay. Let's take a look here. So the write point will from 0 to 7. Okay. Here is 0, 1, 2, 3, 4, 5, 6, 7. From 0 to 7. In binary mode is 000 to 111. This is binary format. Okay. So there is 3 bit 1, 2, 3. So we define the write point from 0 to 2. Okay. Similarly, you will see the read point is also from 0 to 7. Okay, from 0 to 7, and it also from in the binary mode, in the binary format, is from 000 to 111. Okay, so we also defined the we copy it and pass it. We define the read point as from 2 to 0, from 0 to 2. Okay, 3 bit. Okay. So here we have a count variable to present the FIFO empty or FIFO full. Here, so we need to define this variable as register from 3 to 0. So you will wonder why it is from 0 to 3, or you can say from 3 to 0. Why? Okay, let's take a look. So here is FIFO empty. This value equal to 0. Here is FIFO full. This value equal to the depth. So we already defined the depth is 8. So the count will from 0 to 8. And if you see it in the binary mode, it's from 000 to 100. So it's 4B. Okay, it's 4B. So we define the variable from 0 to 3. Okay. Okay. So this is write point, read point, and a count. So now we will able to define the FIFO full or the FIFO empty. FIFO empty is this one equal to 0. FIFO full is this one equal to depth. So let's coding it. Okay, so we use assign full, then equal to count. When count equal to depth, you can write it like this: 1 and 0. You can write it like this. Which means if this one equal to depth, which means 8, then the FIFO is full, equal to 0, equal to 1. And then if this one not equal to depth, the full will equal to 0, means not full. Okay, so you can write like this, or you can simply write like this. We copy it and paste. We can just simply write like this. Okay, so it's also the same result if the count equal to depth, the full will have the value 1. This is the truth. If not, the full will have the value 0. This is false. Okay, so this one have the same result with this one. Okay, so similarly, we can have the empty signal. Okay, for this one, the count equal to 0, right? You can see from here, this is depth FIFO full, and this is FIFO empty count. Okay. Okay, so we already have the full and empty signal. Okay, so the next things we handle the write. We handle the write point. Okay. Next things we handle the write. Okay. So here we give the always. Okay. This block is to handle with the write process. Okay. Here handled with the write process. We also added the negative age reset and into the sensitive signal. Okay, so here, of course, the first things we use if. We use the if. Okay. If else. We use the if to set the reset signal first. Okay. So this is the reset. Because we handle with the write processor, write data, so we make the write point as 0. Okay, as 0. Okay, and the next step, if the write enable equal to 1, which means here, okay, write enable to write it. Okay, if we enable to write it, so we begin put the data memory, put it into the FIFO. This is the current write point, and then we put the data into the FIFO, and then we make the write point edit 1. Okay, so this is a write process. Okay. Okay, we finish the write process like this. Okay, so the next step we will finish the read process is similarly. So here we just copy the read part here. Okay, so this is a read part. Okay, save it. And this is a read process. Okay, the always block, clock reset. And here we reset the read point. This here reset write point. Here is read enable equal to 1. Here it's write enable equal to 1. Here we put the data, input data, inside to the FIFO here. Here we read out the FIFO write point data to the data out. Okay, so this increase the write point, increase read point. Okay, so this is a read process. This is a write process. The next one is the most important one. We handle the count value. Okay, we handle with this one, a count value. Okay, so for the count value, we previous video we analyze it. We get the table like this, the relationship between the write, read, and count. Okay, so now we begin to coding it. Okay, so the first thing, of course, we need the always block. Okay, always block, and then we just copy this part, will be fine. Okay, and here we also have the end. Okay, the first one. Okay, so the first thing is the reset. Okay, reset. So if else, okay, it's not here, it's here. If here, so this is reset here, so we copy this one, reset process, And here we reset the count value. We set the count value equal to 40. Okay, so this is 4B, and for this one actually is 3B. Okay, and this one is also 3B. Okay, so this value is 4B. Okay, we divide it here. Okay, so here we use the case. We use the case language, case. Okay, so the case we will see here. Okay, this is very important. Okay, write and read and account. The write read count relationship, how we coding it? So we combine the write enable, this is write enable, and read enable together, and then we will have the condition like here is 2-bit 10. Take a look here, 10 is 2-bit. Then the count value will increase by 1, right? Okay. 10 increase by 1, the count value. Okay. So we increase it by 1. Okay. Next one, this is 0, 1. For 0, 1 is decrease by 1. Okay. So we copy the first one, copy and paste, change it. So this is 0, 1, and this is minus. Okay, so this is minus. So take a look here, 0, 1, minus 1. Okay, 0, 1, minus 1. Okay, so the next one is 1, 1. Okay, 2B, right? Here is 1, 1, and the value keep not change. So it's here, not change. Okay, and the next one, 0, 0, is also not change. Okay, next is 2B. 0, 0 also didn't change anything. Okay, here we also keep the default value as not change anything, didn't change anything. Okay, so this is handle with count value. Okay, this came from this table. We analyzed this table before in previous video. Okay, so you will see here actually quite simple. Okay, let's move it. This one is actually quite simple. Okay, so the first thing is define some variable. Next thing is to get the full signal and empty signal. Okay, next one is write processor and read processor and count value. So the write module devices, and we will say here we will take a look here. So these devices will according the full signal to write data or not. These devices will according the empty signal to read data or not. The read and write, this is the read process inside the FIFO. This is the write process inside the FIFO. And this is full empty. Okay, so this is the coding for the Synchronous FIFO version 1, version 8, you see. Okay, so next video we will create the test bench to test it, to see this FIFO will generate the correct full signal or the correct empty signal will generate these two signals correctly or not. Okay, thank you for your watching. This is Michael. See you next time.